Good morning, everyone. My name is Henrik Hintze, and I'm here to present the next company for you. The company we are going to listen to now is called Freemelt, and this is a company that we initiated coverage of today. With that said, I hand over the word to Ulrik Ljungblad, the CEO of Freemelt.
Thank you very much, Henrik. So I will talk about Freemelt. It's a company that started about 5 years ago, and we've made a journey until now, and the journey is going to continue. So what are we about? We intend to become one of the globally dominant manufacturing companies, actually. So that's quite a big target. And if we look at the surroundings in this area, there are ancient technologies. Casting and forging are really big industries where this dates back 6,000 years or more. So our mission is to develop advanced and robust 3D printers that compete with traditional manufacturing in productivity, but that is vastly superior in part quality in many applications. So where is 3D printing today? It's a midget in this world. So looking at the size of tools and systems in competing technologies in metal manufacturing, you have the ancient technologies of forging and casting dating back many thousand years. They are dominant together with machine tooling and welding that came a couple of hundred years ago or so. And 3D printing has just started the journey. So on this slide, you see the comparison to 3D printing. Still, there are a huge number of companies now applying 3D printing for metal manufacturing. So in short, 3D printing is a layer-by-layer manufacturing technology, working by solidification of a base material according to a unique pattern in each layer to form a three-dimensional solid part. A part that could look like the one you see on the right side in the image. A part like that is, of course, impossible to make with any other technology than 3D printing because it's so complex. But what is above this also, or in addition to this, is also that it's possible to make new materials or materials that are superior in quality, because this printing technology is in essence sequential casting, so one can control the material properties during the sequence of manufacturing of a part. So we use Freemelt, we use electron beam, powder bed fusion. Electron beams has a high beam power, which means that we can use this for a high productivity, fast producing machine that is superior in speed compared to competing technologies based on laser technology. One of the big advantages about 3D printing is that it's a sustainable manufacturing technology. One of the aspects creating this advantage is that it enables weight reduction. So looking at these two examples from Airbus, a wing bracket and a bionic design, lightweight design for a motorcycle, the weight reduction is 30 to 40%, which means actually that one can bring up 30 to 40% less material from the mines in order to produce these parts in the future. That is a huge advantage in environmental friendliness for the future. So 3D printing is key for reduction of use of raw materials in manufacturing. In Freemelt, we come from a background at Arkham. All of us, the founders, we were 7 founders originally. Arkham is a Swedish 3D printing company that was founded 25 years ago now, sold their first system 20 years ago. They delivered their first system to customer in 2003. And they focused on aerospace and implants in the application that they are offering to their customers. In 5 years ago, they were bought by General Electric. General Electric bought Arkham for 6 billion crowns. They also at the same time bought a German company, laser-based company called Concept Laser at that time. What's interesting is that only the last week, another of the big companies in the business, SLM Solutions, there was a bid placed on them for exactly the same amount, actually 6 billion Swedish crowns from the Japanese company Nikon. And so Arkham is basically where we come from, where we have our roots, and then we started Freemelt in 2017. So today we are 35 people at Freemelt with a great background, a variety of background, experienced people, the founders, and more with a background in 3D printing. We have more than 100 work years experience in 3D printing, but also young, creative, new engineers that brings a lot of sort of enthusiasm and also knowledge to the team. So we have a very good team, I must say. This is our first product, Freemelt 1, that was sold and delivered to the first customer in 2019. So exactly 2 years after we founded the company, we delivered this to the first customer, which was a university in Germany. This is an open source software electron beam powder bed fusion system. It provides unlimited user control of every process parameter. And our technology is something that we developed early on in the company's startup phase. So with this technology that we employ in the electron beam technology here, we are superior to our competitors because it's based on different principles, where we use a so-called diode electron gun and where we have a laser heated cathode. This enables more robustness, but it also enables a better spot size at the high beam powers, which means that we can melt with better properties in a faster pace with our electron gun. We have also used technology from accelerator facilities for the magnetic coils that control the beam positioning, which is very accurate in the way that we apply that. We also have other technologies that we developed, like a backscatter image detector. That means that we can monitor the build layer by layer throughout the build, and thereby ensure quality in an industrial sort of context. Open source. There is a lot of benefits in open source, especially in 3D printing. For our academic customers, they love this. They can set the parameters any way they want for their research. They can even update the source code of the machine to some extent. So they can add their own equipment and integrate it with a machine software. From the industrial point of view, this is also really advantageous. Often there are regulatory businesses that use 3D printing. There it's very difficult to fulfill the demands from a regulatory standpoint, because it's important to know exactly what the printer is doing, and many of our competitors are not allowing that or enabling that to the user, which means that it's hard to implement in a regulatory environment. Another thing is that they can create their own IP, since they can control and develop things themselves in the printer. So also in an industrial application, it's possible to take a big advantage based on the open source nature of our printer. So as I said, we had early market traction. 2 years after the company launch, we delivered the first Freemelt 1 system, making Freemelt the #1 choice for materials development in 3D printing. We are the only ones in the business that has a printer that is specifically developed for material research and material development. So far, we have double-digit numbers of Freemelt 1 installed, and you see on the maps where we have our printer so far. Late last year, we opened up United States as a market, so we have a number of systems also now installed in the United States, and a very big interest from universities and research institutes, but also companies in the US for our technology and our product. Our customers are developing many new materials now. The ones that have had this for now, the ones that had it for longest time is 3 years. So they made a lot of publications and research on new materials. So this is very exciting for us to see what is done in the systems at our customer sites. But there is also a strong interest from industry for a Freemelt production system with industrial applications in new materials. So this is the next step for Freemelt. Going back to the start of the company, we started already right from the start to have a strategy in 2 steps. The first was to develop a printer for research and material research and for academia. And the reason for that is that there's a number of reasons for that. One is that it's easier to get into that market. We have a background from there, but also that there needs to be new materials developed. So that's a very good point of start. And there is a lot of collaboration between industry and academia in this in 3D printing. So I would say that this is implemented. We now have all these systems out in the field, and we're continuing to sell Freemelt ones in a good pace. And the second step in our original plan was to move on and develop an industrial 3D printer. And this is what is going on at the moment. So this is going to be optimized for volume production with manufacturing processes and core technology directly transferable from Freemelt 1. So the strategy is to be able to develop material processes on Freemelt 1 and then transfer them into the industrial printer, which is going to be much more efficient than doing it on a bigger, more expensive system. So in this, we are collaborating with selected industrial partners throughout the project. So they come with input to requirement specification on the printer, and this is now ongoing with a number of different partners. So key components are already fully developed and in use in the Freemelt 1 printer. We have strategic partnership with, for instance, a US company called 6K Additive for supply of quality metal powder. And these 2 systems will then be completely different products as addressing different markets. So with the Freemelt 1, we are targeting universities, research institutes, but we have actually also sold this to 3 different industrial companies to their R&D departments. So there is a strong interest for Freemelt 1. And the industrial printer then will be fully automated and efficient in production and directed towards a few specific verticals where we are aiming this product. And looking at these verticals, so as a company, we are addressing research, where the customer can use an unlimited number of material options. The industrial printer will be focused on implants in a special titanium alloy that is used for implant manufacturing. It will be focused on fusion energy and medtech applications in pure tungsten, which is a very interesting material that we're working a lot on at the moment. And the third vertical where we'll direct this effort with the industrial printer is on ultra pure copper, where there is also interesting aspects with the technology compared to all the other competing technologies in 3D printing. So these are the verticals selected based on unique technology advantages and fast expected market growth in all of these ones. Looking first at a business case of titanium orthopedic implants. This is a business that worldwide has a turnover of about $50 billion to the end market. What's interesting with this is that although it's growing at a relatively modest pace, about 3% per year or something like that, the amount of additive manufacturing in this is today it's about 3-4%, but the growth is about 20 to 40%, depending on which type of implants. So the projection is that 3D printing will be, in a number of years, be the main technology for production of orthopedic implants. So there's a huge growth inside this area, this fairly big market area. Moving on to the tungsten case. There are emerging markets using tungstens. We see multiple cases for use of tungsten with electron beam powder bed fusion. There's a strong advantage with electron beam because we produce in a vacuum system, which is contrary to our competitors, and we produce at high elevated processing temperature. And that means that we can avoid cracking in the material. That is a big setback or a big problem when producing this at room temperature or something like that. So we see that we are very well positioned with our technology towards tungsten applications. And the areas that we're working is on medical and industrial CT scan equipment. So there's a collimator part that is used in tungsten in large numbers. And we also in discussion with several players in fusion reactors, which is an energy system of the future, where basically what one can say is that one creates and sustain the sun inside a confinement. So it's extremely high temperatures, and that means that the inner walls of this confinement has to endure very high temperatures. And here tungsten is the best material. It has the highest melting point in the periodic table. And there's hundreds of thousands of parts that will be used in each of these nuclear fusion reactors in the future. And there is also a number of private players entering this field now. After 30 years of development in big scientific projects, now there is a huge interest from private industry also in fusion technology. The third material, copper. Here we are a little bit behind compared to the other two, but we see that there are huge applications. And the biggest ones here being, for instance, heat exchangers, but also electromobility, so electric drives and so on, where, of course, there's a big growth in the world today with the electrification and the battery technologies. So, finally, an event history for Freemelt. It was started in February 2017, investment from private investors. We had a couple of investment rounds since then. First system shipped to customer 2019. In 2020, we went into the COVID crisis, of course, and the universities locked their doors and went home, so they were easy to talk to, but they didn't make any investment during that year. So we did measures to mitigate the influence of COVID-19. 2021 came back strong, and we made also a pre-IPO investment in that year and a listing at Nasdaq First Growth in July. This year has been increased sales of Freemelt ONE and also much focus on development of the industrial printer. So finally, summary. Freemelt developed a new high-power electron beam 3D printing technology. We're on the market with customers using the technology for material development, and we're now taking the next step in commercializing our technology by developing industrial printer. We embrace open source for fast scaling, and we will see expansion of sales in selected market verticals. And here you also see some sort of appreciation of Freemelt from various market reviews and so on. So thank you very much.
Thank you, Ulrik, for that presentation. Let's move on to some questions. Next month, Freemelt is getting a new CEO. Could you perhaps tell us a bit about that decision?
Yes, so Daniel Gidlund has decided to join us. He comes from Sandvik. He's been working on the aftermarket area, sort of, and he brings in a lot of industrial expertise into Freemelt. So the decision is based on the fact that we are growing. We are growing as an organization, and we are growing in every sense. And we are now looking to bring in more and more experience in from industrial companies, which will be necessary for establishing us in the industrial field and also to be efficient going forward.
Sounds good. Currently, your revenues come mostly from machine sales. How do you think that will develop in the future? Will there be any recurring service revenues?
There will certainly be recurring service revenue. I mean, with the market where we're selling today, it's a really good market. Actually, it's growing very fast. The research market is expected to stay to be the fourth biggest area in a few years from now. So it's a good market from that point of view. But of course, as a university, it's harder to find money for service contracts and so on. It's a completely different picture when we release an industrial printer. There, a large or a substantial part of the revenue over time will come from service contracts and offering tailor-made solutions for the industrial customers. So I expect that to become more and more important as we enter the market and start to see numbers of the industrial printer.
Okay. You touched a bit upon this before, but what are the main reasons that a customer would choose EPBF technology over other 3D printing technologies?
Yeah, we thought about this a lot, of course. So that's a good question, because there are laser-based powder bed fusion is today much bigger than electron beam-based powder bed fusion. And I want to also say, just to make a complete picture, there is a number of other 3D printing technologies also, aside from powder bed. But powder bed is by far the most dominant and predicted to stay that way also for the next 5 years. So in that context, it's interesting to compare with the laser-based systems. And what we see here is a partly overlap and partly not overlap. Some materials are more suited for laser, for the laser side. But some materials are definitely much more suited for electron beam powder bed fusion. And this is also the background for the choice of the markets that we're entering. We see that it's very hard for the laser-based companies not only to compete in productivity, but even in these markets in quality or possibility to print in these materials. Tungsten, copper, titanium also to some extent. So with copper, it's extremely hard to print at room temperature where they have their temperature point. With copper, it's a different story. With a laser, it's extremely reflectant. So the material copper is reflecting very much. So it's very hard to get any beam power into the material. That means that it becomes very slow. While with electrons, we get much more power into the material there. Overall, also, we have a high. It's easier to make electrons than coherent photons, actually. So it's a technology that holds the potential of becoming faster and more productive, and thereby cheaper to use in the future. There's also another thing, and that is that we can move the beam very much faster around, which means that we can build processes in both that are faster due to that, but also that enables other material properties based on the fact that we have that freedom.
All right. Thank you very much for those answers. I think we'll leave it at that.